Welcome to my new video, and in this video we are going to discuss about the basic parts and the working of a transformer in less than 10 minutes. So let us not waste our time any further and zoom into the image to look at the various parts. So to understand the various parts of the transformer, we are going to go in a clockwise sense, starting from here, which is the conservator tank. What is a conservator tank? It is an oil reservoir. Now the question is, why do I really need an oil reservoir? So this main tank is basically filled with oil. You definitely know this, and the winding is also basically housed inside the main tank, right? So whenever the load is connected, the heating will happen and this oil is going to expand, and for the expansion it definitely needs a secondary space which is being provided by the conservator. Whenever the transformer is on load and the oil heats up, the oil is going to flow from this particular pipe to the conservator tank, and whenever the transformer cools down on no load or less load, the oil is going to travel back into the main tank. So this is the basic function of the conservator tank, and let us proceed further into the radiators. What is a radiator? Radiators are basically these particular fins. You see these fins right here, no? So the purpose of the radiator is basically to help the cooling of the oil. What will actually happen is, as the oil heats up, it is going to flow inside the radiator and through a larger surface area by natural ways of cooling. Say the air coming here is going to help the oil cool a little bit faster. So this is going to be the basic function of a radiator. Now let us move further into the main tank. I've already told you the main tank is the housing of core and the oil. What is this particular small part? You see the small part here? This is basically the oil sample collection point or the drain point. The purpose of this particular point is basically to remove a little bit of oil from the transformer for, say, the performance of DGA. If you want to perform the DGA on the transformer oil, DGA stands for dissolved gas analysis, which is basically analysis of the health of a transformer. So this particular little thing is going to help you to collect the oil sample for the testing. Proceeding further, the important thing, the most liked part of the interviewer. So these are the bushings. What are the bushings basically? So inside I have, say, a 3-limbed core is there. I have the winding here, and I have basically a star connected winding. So this is R phase and this is Y phase, and basically this is B phase, and this little guy is our neutral point. What will happen is these bushings will basically provide an outlet path for the external connection. The R is going to be connected to this bushing, the Y is going to be connected here, and the B is going to be connected here, and the neutral point definitely is, say, going to be connected here. So bushings are basically the output electrical contacts of the windings of a transformer. Now sometimes the interviewers tend to ask you if you can, by observing the bushings of the transformer, tell whether it is a step up or a step down transformer. In that particular case, you have to ask the interviewer on which is the primary side. Suppose he says that this is the primary side, you have to look at the size of the bushing and say that since this is the primary and the insulation level is high on the primary side because the size of bushing is very large, so this is basically the high voltage side, this is basically a low voltage side, and this particular transformer is delta to star step down transformer. This is how you're going to answer. So now let us proceed further to one of the important part, that is the working of a transformer. So to see the working of transformer, you have to see that this is the core of the transformer, these are the windings of the transformer, the primary winding, this is the secondary winding of the transformer. The primary winding has 1 2 3 4 turns, secondary has 1 2 3 4 5 and 6 turns. So this is basically 4:6 transformer. Now, to understand the working of the transformer, you have to see that as soon as I'm going to connect a voltage V1 here, a current I1 is going to flow, which is going to set up a flux phi, which is further going to set up an EMF E2 here. And this particular EMF E2 is what is available on the load side to us. This particular, and in here I'm going to connect whatever load I need. So as soon as I connect the load here and it draws a current I2, this current is going to increase to say I1 plus I2 dash. This is how the transformer works, and let us quickly see into a small derivation so that you can have a concrete understanding and the classic formula of the transformer can be derived. So if I see here, the phi 1 can be basically proportional to I1. Also, you have to understand that EMF per turns for primary is equal to EMF per turns for the secondary. Why do I say that? Because E1 is equal to N1 d phi 1 by dt, Faraday's law, and E2 is equal to basically N2 d phi 1 by dt. So now E1 by N2 will be equal to E1 by N1 will be equal to E2 by N2, that is equal to EMF per turns, right? So you have to understand that the EMF per turns for the primary will be equal to the EMF per turns of the secondary, and hence the classic equation from these two equations can be derived, which comes out to be E1 by E2 is equal to N1 by N1 by N2, So this was all about the working of the transformer and the basic parts. If you have any doubt, you can ask me in the comment section. I'll be happy to answer all the doubts. And thank you for watching the video. If you like the video, please subscribe to my channel and definitely give a thumbs up. Thank you very much. Signing off.